In the next example, what we're going to do is we're going to use our information that we've learned throughout the lesson to help us solve problems involving different real life or real world applications. And this one just happens to be on a clock. So we're going to look at this problem. It says a 3-inch long minute hand on a clock shows a time of 45 minutes past the hour. What is the new position at the end of the minute hand relative to the pivot point at 10 minutes past the next hour? And what they're doing is they're giving you kind of a picture of this to help you kind of visualize what's going on. When this thing started, our minute hand was over here on the 9, so it was 45 minutes after the hour. We want to figure out what are the coordinates of this minute hand when it gets to 10 minutes after the hour. So what I'd like to be able to do is I want to position that clock on the coordinate plane. So the center of the clock is here. The minute hand starts at the first time right here on the positive x-axis at 45 minutes, so at the 9. And then it rotates to 2. Well, around the clock, 360 degrees, we've got 12 equal parts, so 360 divided by 12. That means that each individual number here is a 30-degree rotation. So at 12 o'clock, and we go down 1, 2 more, that means we've rotated an angle of 30 and another 30, or 60 degrees. So we have 60 degrees that we've rotated past 12 o'clock. So I'm looking at this, and I want to go back to the angle in standard position. So in standard position is the way we want to look at all of our angles. So it may have started here on the negative x-axis, but then it rotated around until it got to the 2 on the clock hand, which we figured out is 60 degrees past a 90-degree angle. So really what I'm going to end up using is this reference angle sitting right in here. And we're going to find the reference angle from the position at 2 down to our positive x-axis, when we know that this angle is 30. So always opposite the 30. I'm going to mark some other stuff on here. Maybe we're at 60. The radius of this clock hand was 3. I forgot what they were, 3 inches. And we're going to find the position that the minute hand is relative to the center of the clock. So it's just like being on our coordinate plane. We want to know how far x we are, what's our x position, and what's our y position. So to find that, what I'm going to do is use a trig ratio. To find the x-coordinate, I'm going to use the cosine. So the cosine of the 30-degree angle that we have has to equal x over our 3-inch radius. So that means x is equal to 3 times the cosine of 30. And I'm going to just hold off to do that calculation until I finish the other part. And then to find the y position, I'm going to use the sine value of 30, because the sine is going to help me find the opposite side of the y value, and that's y divided by 3. So that means y is equal to 3 sine of 30. Now all we have left is to run those calculations and put in our approximate positions. So I'm going to go back to the home screen, clear that, check the mode, make sure I'm in degree mode. It is. So we got 3 cosine of 30, and that equals 2.59, so let's declare it at 2.6. So x is approximately 2.6. And the other thing that we can do is we can take 3 times the sine of 30. So we take 3 times the sine of 30, enter, and we get 1.5. So the y is exactly 1.5. So the new position is approximately 2.6 comma 1.5. So now the only thing that would be different is if they were really asking for the exact values of this. If they're doing that, then we'd have to come back to our unit circle and go back to what we know about our 30, 60, 90 right triangles. They're not declaring that, so we'll be satisfied with this result, and we'll move on to our next result, next example.